guys. So when writing names of chemical formulas, the first thing you have to do is ask yourself a few questions. So we're going to create ourselves a flowchart, and then we're going to do some practice problems in order to help us. So the first thing we need to ask ourselves is, let's word it as, are there exactly 2 elements in the formula? Okay, so if the answer to that is yes, okay, then you have to ask yourself another question. You say, is there a metal? Okay, because as we know that if there is a metal, this means if the answer is yes, then we know the compound is ionic. But if the answer is no, then it is covalent. Okay, and that's going to change how we name things. If the answer to our original question, are there exactly 2 elements? If it's no, there are 3 or more, then that means you have a polyatomic ion located on the back of your periodic table. Okay, so we're going to have to look at that there. And so if we have a polyatomic ion, that also makes it ionic. So with covalent compounds, the things you have to ask yourself are, first, it breaks down into element number 1 and element number 2. Okay, and the way that they're listed in the formula is also the way they're going to be written in their name. So element number 1, what you do is you change the subscript into a prefix. Okay, and so the various prefixes that we have, mono means 1, di means 2, tri means 3, tetra is 4, penta is 5, hexa is 6, and then I'll finish writing the other ones over here. Hepta means 7, octa means 8, nona means 9, and deca means 10. Okay, now once we change it into a prefix, we just add that prefix to the beginning of the name. So we just add to name, and prefix means beginning or before, so you add it before the name. Now for element number 2 for a covalent compound, we add our prefix, if appropriate, and change ending to IDE. And one thing I forgot to mention with adding the prefix, the only thing you don't do is it's except for mono. You do not add mono to the beginning of the first element. You can add it to the beginning of the second element though. But so you add the prefix and change the ending to IDE. And so that takes care of covalent compounds. Ionic, a little more tricky. So the first thing you know is that it has to be, ionic compounds are split into 2. Okay, you have your cation and you have your anion. Your anions are negatively charged, cations are positive, and the positive things always come first. So cations are always written first. And you ask yourself, is it a polyatomic? Okay, because you potentially could have gotten there through this pathway to the right about having more 3. But if you got through the left pathway of there's still only two elements and there is a metal, then you still just need to figure out, is your polyatomic, or is the cation a polyatomic? And so if your answer is yes, then you name it off the chart. You don't really have to do anything to it. In fact, anions have the same question, or is it a polyatomic? Because while polyatomic ions are most commonly anions, they can also be cations. Okay, but if the answer to our cation is a no, it's not a polyatomic, you ask yourself, is it a transition metal? Now, remember, transition metals are located in the D block of the periodic table, or columns 3 through 12. And so if the answer is yes, you need to use Roman numerals. But if the answer is no, then you just name it. You just write the name from the periodic table. Okay. Now for your anion, okay, if it's not a polyatomic, then you name it and change ending to IDE. Okay, so this is our flow chart. That's what we've got. So this, however, is only as good to us as we are able to use it. So from your homework, there were several problems that you had to do practice problems for. Why don't we just go ahead and do some of them. I'm going to write the problems off on the side and we'll work on them. So a few of them, and I'm just going to kind of skip around. We have CO, we have P2O5, we have PBr3, PCl3, NAF, CuBr2, NaHCO3, NaOH, and let's just do one more rounded off, LiNO3, and perhaps one more, NH4, 2, SO4. Okay, so let's use our flowchart to help us figure out how we name these compounds. All right, so we'll use our flowchart and we'll figure it out. So the first one, CO. Are there exactly two elements? The answer for that is yes. So we're going to go down this way. And we say, is there a metal? Well, if we look at C, which we know is carbon, carbon is to the right of the staircase on your periodic table. So it's not a metal, it's a nonmetal. And oxygen is also a nonmetal. So our answer here is no. So that means that this compound is covalent. And if it's covalent, that means we're going to be using our prefixes. So we look at our first element, C. We change the subscript into a prefix. Well, I don't have a subscript, but that just means that chemists are lazy, and so that means we have only one carbon, and we don't use mono, so we're just going to name it as carbon. Okay, so we have taken care of all of this here. Okay, the next thing we do is element number 2. So we have to do the second element. And we say, okay, well, we add the prefix and change the ending to IDE. So O, the prefix is 1, so that's monoxide. Okay, we changed oxygen to end in IDE, and we put the prefix mono in front of it. So I'd have carbon monoxide. And so I have used all of this information. And so I have completed my flowchart and named my column, or named my compound. Okay. So if we do the same thing for phosphorus, 2 oxygen 5, P2O5. Okay, we know our first compound, phosphorus and oxygen are both nonmetals, so I'm going to be over here in these covalent compounds. So it would just be diphosphorus pentaoxide. And then PbR3, there are 2 elements. There is not a metal, so I'm covalent, and so my first element is phosphorus, but I'm not going to put mono in front of it because it's the first one. And then I would have tribromine, changes to bromide, and this is a TR, not a B, so tribromide. And we'd have something similar here. We'd have phosphorus trichloride. Now, when we get to NaF, there are exactly 2 elements, but for the first time, we have to answer yes for the metal. Sodium is in fact a metal. It's to the left of the staircase, so that's going to make it an ionic compound. Okay, and so we look at our cation, which our cations are always written first, and we say, okay, is it a polyatomic? And I didn't come through the route of the polyatomic ion having 3 or more, so the answer is no. I don't have a polyatomic. So I'm just going to go this route. And I ask myself, is it a transition metal? Well, the answer to that question is no, it's not in those columns, so I'm just going to name it. So that means I'm just going to write Na as sodium. Now, my anion, okay, I have to come this route. My anion, it's not polyatomic, okay? And so I'm just going to name it and change the ending to IDE. So that means fluorine would become fluoride. So I just have sodium fluoride. So if I look at CuBr2, I have exactly 2 elements. There is a metal, because copper is a metal, so I'm ionic. I'm not going to have polyatomic, so answer no, it's not polyatomic. But when I look at it as a transition metal, the answer to that question is yes. There is a transition metal. Copper is a transition metal, and so I'm going to need to use Roman numerals. So I'm going to write this as copper with parentheses for Roman numerals. Then I'm going to name my anion bromide. And in order to figure out the Roman numerals, I'm going to just create a chart here because we have to look at our positives and our negatives. I have 1 copper and I have 2 bromines. Now, in the oxidation video, we discovered how to figure out the oxidation state, and bromine is in column 17. It will have a -1 charge. That means total this side adds up to -2. And if the negatives are -2, then the positive side has to be equal but opposite. So I have a +2 charge here. Now this +2 charge has to be distributed to everything in this column. Well, since I only have one thing, that must mean my copper ion has a +2 charge. So I put a Roman numeral 2 in my parentheses. Now if I look at NaHCO3, I am again getting something new this time. Okay, I do have 3 or more, so that means I have a polyatomic ion, which means I'm going to be ionic. And so when I look at my cation, okay, we have to decide what is going to be the polyatomic ion here. And the trick with that, when you're looking at NaHCO3, is if you ever see multiple oxygens, you're most likely going to have everything that's with that as the polyatomic. Okay, and the reason why I know it's going to stop at Na is we have to have one element at least for sodium or for our cation and one for our polyatomics. And the more that you use your polyatomic ion sheet, the more you'll begin to recognize them. But HCO3 is also called hydrogen carbonate or bicarbonate on your periodic table. And we know that Na is sodium and not a transition metal, so it has sodium hydrogen carbonate, which is often sometimes called sodium bicarbonate or baking soda. And so for the rest of these, I'm actually just going to help you practice figuring out the ionic compound, or the polyatomic ion, excuse me. So this last one, we have OH is going to be our polyatomic. NO3, we got those multiple oxygens again. And then anytime you see parentheses, whatever's inside the parentheses is polyatomic, but also notice over here we have two elements, so SO4 must also be a polyatomic ion. So both our cation and our anion in that case would be polyatomic ions. So hopefully this helps you and you're able to write your names and able to do your homework. Good luck.